Welcome to the video on Lesson 5.2 Common Factors. Lesson 5.2 corresponds to textbook pages 214 to 223 in the McGraw-Hill Ryerson textbook. By the end of this lesson, you will be able to determine the greatest common factor and least common multiple of whole numbers, determine the greatest common factor for a polynomial, write polynomials in factored form, and apply your understandings of factors and multiples to solve problems. This is part 1 of the tutorial video, and part 2 will be the second half of the notes. First, let's look at some terminology that you need to understand for this topic. Factor is any number or variable that when multiplied with one or more other numbers or variables forms a product. So if we are looking for the factors of 12, we want to know all the numbers that can be multiplied to get to 12. Or you can think of it as what numbers is 12 divisible by? So if we list them all out, 12 is divisible by 1, 2, 3, 4, 6, and 12. 1 times 12 equals 12, 2 times 6 equals 12, and 3 times 4 equals 12. So 12 has 6 different factors. If we look at the factors of a squared b, we want to know what could be multiplied together to get a squared b. A squared is like saying a times a. So a and a are factors of a squared, and when we multiply b onto the end of that, b is also a factor. Okay, so let's look at the greatest common factor, or GCF, of two terms. The GCF is the largest factor shared by two or more terms. So let's do an example to show this. Find the GCF of 12 and 28. So we need to list the factors of 12 and all of the factors of 28. Again, the factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 28 are 1, 2, 4, 7, 14, and 28. So if we look at the number that they share, or numbers, factors that they share in common, we see that they have a 1 in common, a 2 in common, a 4 in common, and that's it. So when we're trying to identify the greatest common factor, we're looking for the biggest factor that they share in common, which in this case is 4. So the greatest common factor of 12 and 28 is 4. Another term that you need to be familiar with is the lowest common multiple, or LCM, of two or more terms. The LCM is the smallest multiple shared by two or more terms. So if we're looking at finding the lowest common multiple of 6 and 8, we need to list multiples of these two numbers. First of all, multiples of 6 are 6, 12, 18, 24, 30, etc. Anything that is multiple of 6. Multiples of 8 are 8, 16, 24, 32, etc. As soon as we find one that they share in common, we can stop because we're just looking for the smallest one. The smallest common multiple that they share is 24. So the LCM of 6 and 8 is 24. Listing out all the factors or all the multiples of numbers can be a little tedious. So if you have a TI-83 or 84 plus calculator, you can use it to help you find the GCF or the LCM of two numbers. There are tutorial videos on how to do this with calculator steps on the website, where you would also find these tutorial videos. But just a quick overview is, to find the greatest common factor, it's actually called the greatest common divisor on the calculator. It's the same thing though. To get the GCF, or GCD, you would select the Math menu and scroll to the right one menu to get to the Number menu. Then scroll down and select number 9, GCD. It will open a bracket for you and take you on your main screen, and this is where you type in your numbers that you want to find the GCD for. But you have to separate the numbers by commas. Once you've typed in the numbers separated by commas, close the bracket and hit Enter. To find the LCM, you go to the same menu. Select Math, scroll to the right to get to the Number menu, and then scroll down until you see LCM, or number 8. Select Enter, or select number 8, and it'll take you back to the home screen where you can type in the numbers that you need to find the LCM for. Of course, separate the numbers with commas and then close your brackets and hit enter to find the answer. Unfortunately, your calculator won't be able to identify a greatest common factor of polynomials. So we have to do that by hand. To find the greatest common factor of a polynomial, you need to find the GCF of all the coefficients and variables for all of the terms. So, when you're given a polynomial, you have to identify how many terms there are and what factors all of the terms share in common. So let's do an example. To find the GCF of x squared yz plus x squared y, we first want to list all of the factors of each term. For the first term, x squared yz, it has factors of x, y, and z. Remember, x squared means there's two x's multiplied together. The factors of the second term, again we have an x squared, so we have x and an x, and then multiplied by y. So if we look at all of the factors they share in common, because we're looking for the greatest common factor, they each have an x, another x, and a y in common. So we put those together in the greatest common factor. So the most factors they share are x, and y. So the GCF of the polynomial x squared yz plus x squared y is x squared y. And it's x squared because there was two x's that they shared in common. Okay, so let's look at an example of finding the greatest common factor of a polynomial when the polynomial has coefficients. Finding the greatest common factor of 16x squared y plus 24x squared y cubed, we can use one of two methods. Method 1 is to use prime factorization for the numbers. In topic 4, we looked at how to find the prime factors of a number, so we'll review that here in a second. Method 2 is to list all the factors and compare to find the largest common factors. And this is what we've kind of done in the previous examples. In method 1, we need to find the prime factors of 16. So we're going to break down 16 using a factor tree until all of our branches end with prime numbers. 16 is divisible by 2, which gives you 8. 2 is a prime number because it can't be divided by anything but 1 in itself, so we just leave that branch. But 8 can be divided further into 2 and 4 can be divided further into 2 and 2. So the prime factors of 16, and we're going to list those out here as a list, is 2, 2, 2, and 2. There's 4 of them, and these were the ends of the branches in our factor tree. For variables, we just break it apart again like we did before. X squared is x, and y is just a y. For 24, if we list the prime factors or do a factor tree for it, we're going to do the same thing as we did for 16. We're just going to divide it until we have all prime numbers. 24 can be divided by 2 to get 12, 12 can be divided by 2 to get 6, and 6 can be divided by 2 to get 2 and 3. So all the ends of the branches are 2, 2, 2, and 3. Next we have x squared. So we list for our x squared term, there's two x's, x times x. And for y cubed, when a number is cubed, that means it's multiplied by itself 3 times. So we would have 3 y factors. 16 and 2 share 3 2's in common. Or 16 and 24, share 3 2's in common. X squared, both terms have 2 x's. And in the last part, both terms have 1 y in common. Okay, so all of these common factors can be put together to form the GCF. The GCF would be 2 times 2 times 2, which is 8, x times x, which is x squared, and 1y. We can find this greatest common factor using method 2 as well. Method 2 is to list all the common factors and then identify the largest one. So for 16 x squared y, we want to list out all the factors of those parts. So 16 has factors of 1, 2, 4, And because 4 times 4 equals 16, we just list 4 once. Then we have 8 and 16. For x squared, we have x times x, so 2 x's. And for y, we just have 1 y. For the term 24x squared y cubed, we have 24 x squared and y cubed as our parts of our factor, or parts of the term. So for 24 is divisible by 1, 2, 3, 4, 6, 8, 12, and 24. X squared has 2x factors, and y cubed, again, is y times itself 3 times, so there's 3 y's. The largest or most factors that they share in common are, if we look at the numbers first, the largest number they share in common is 8. They also share a 4, a 2, and a 1 in common, but we want the biggest one. They share 2 x's in common and 1 y in common. So we put these together to form our greatest common factor, which is 8x squared y, which is the same as what we got in method 1. Alright, so now we know how to find the greatest common factor in a polynomial. But how do we use that? When you're factoring polynomials, you are going to need to use the greatest common factor in order to bring it out of the polynomial. Factoring is the reverse operation of multiplying. So if we look at an example of multiplying a polynomial, where we use the distributive property, you have to take the 5 that's outside of the brackets and multiply it by everything inside the brackets. So you'd have 5 times x, which is 5x, and 5 times 2, which is plus 10. This process is multiplying by getting rid of the brackets. Factoring is the reverse of this operation. It's when you have a polynomial and you need to go to a form with brackets. So, how can we do that? To factor a polynomial, you need to identify the greatest common factor of the coefficients and variables in every term first. So this is what we've been doing in the previous examples. Once you've identified the greatest common factor for all of the terms, you need to divide each term by that greatest common factor. Once you've divided each term by the greatest common factor, we write the greatest common factor as one of the factors of the polynomial out front. The second factor is in brackets and contains all of the leftovers of the terms after the greatest common factor was divided out. So basically, after you divide, what are you left with? That's what you put in the brackets. Finally, you can always check your answer after factoring by multiplying to see if you got back to the original polynomial. Multiplying is using the distributive property. In the next video, in part 2, we will look at several examples of how to factor polynomials.